Hello, it's 2 p.m. Welcome to the past Big Data Virtual Chapter session. My name is Paco Gonzalez. I'm the past Big Data Virtual Chapter leader. Today we have another great event sponsored by Hortonworks and delivered by Scott. So, Scott is presenting about HBase architecture and use cases. Okay, so this virtual chapter is sponsored by Hortonworks. As you may know, HD Insight is the cloud Microsoft implementation of Hadoop. Hortonworks and Microsoft are strategic partners for Hadoop on the cloud and on-premise. Hortonworks develops, distributes, and supports the only 100% open-source distribution of Apache Hadoop, built and tested for enterprise-grade deployments. It is the only Hadoop-based platform available on both Linux and Windows. I click on it. Great. Hortonworks is sponsored a series of educational sessions that is being a success so far. We had a session about HDP 2.1, another one about Yarn, another one about Hive, and today we're doing HBase. Next session will be February 24th, and it's going to be about Storm. Because you are attending this session, you will enter the raffle of 3 $50 Amazon gift cards. If you are if you're in the session for the whole session, and you also fill the evaluation survey at the end. If you did attend the last sessions, this one and the next one, that means the 5 sessions, and you fill the post-evaluation survey, you will enter into a raffle of a GoPro camera. So let's start with the session. Is HBase architecture and use cases. The speaker is Scott. Scott doesn't need an introduction. He already delivered 3 sessions for this virtual chapter. So thank you very much, Scott, for being here. So go ahead.
Yeah. All right. Well, thanks, Paco. I appreciate it. Yeah. So this is session number 4. It's been a great time. We have one more session left, and that'll be on Storm. And actually, I think that's a really appropriate session to end with, because you'll hear me talk a little bit about Storm here, and Storm will kind of tie everything together. So what we'll find is HBase is sometimes very critical to us, to a Hadoop architecture that utilizes Storm. So please join us for the final session then on in February. All right, so today's agenda, we have a lot to cover. I want to make sure we have enough time to do it. I would like to do a little demo for you too, if possible. But so today's agenda is I want to get a quick review of NoSQL or NoSQL.
No, Scott, I'm not seeing your screen yet.
Yeah. Oh, you're not seeing my screen?
No. So you gotta show your slides. So you are the presenter, but you
I gotta just click show my screen.
So now I see a command window.
Yep. Now I'll get you going here. Let's see. We are. And let me swap this.
Great.
See, we good?
We are good.
Right,
Thank you.
Thanks, Paco. You would think after 4 sessions I would have figured this all out. But, okay.
Great. Thank you.
Every day's a new day sometimes. All right. So, yeah, today's agenda. We're going to do a quick overview of NoSQL. This may, some of this may be kind of the interesting part, especially coming from a relational database background, to kind of get a better understanding of why some of these solutions exist in the market and what their usefulness is. We'll have a quick overview of HBase and how it's structured as a database. We'll look at a fairly new implementation on the screen, on the scene, which I find very exciting. If you're a SQL developer, you should find it exciting too, and that's Apache Phoenix. Finally, we'll take a quick note about HBase HA. We'll talk about use cases and architecture, and then have just a little short demonstration of HBase and Azure, or just a little talk about HBase and Azure and your options there. All right, so let's first look at NoSQL. So there's a thing called CAP theorem. I'm not sure how many people have heard of the CAP theorem, but quite a while ago, I think there were some data scientists at maybe I think it was Berkeley, came up with this theorem, and it's around database systems. And what it essentially says is you have three components to database systems. You have consistency, which means that anytime you insert data into a database system, it determines on whether or not all the users of that system see the same view of the data. So view meaning a consistent view of the data. So if I make an update to a row in a table, does all the other users see that change at the same time? If they don't, then it's considered eventual consistency. If they do, then it's considered consistent. The other option is availability. That is how well the database system reacts to failures, to node failures. And finally, there is partition tolerance. So partition tolerance is pretty simple. Any database system that can be implemented in a distributed architecture like Hadoop is considered partition tolerance. So that way you can lose portions of the database, partitions of the database, and the database will still function. Now the tricky part into the CAP theorem, and what the CAP theorem basically proposes, is that you can only have two of these. So you can't have all three at once. A database system cannot be consistent, available, and partition tolerant. And so this is how most database systems are defined in the marketplace. Your traditional SQL servers and your Oracles of the world, your RDBMSs, are considered CA. They are consistent and available, and that makes sense because if any DBA would know that yes, they're both consistent and available, but they don't run on Hadoop. You can't distribute them over thousands of nodes. Other database systems, like Cassandra, is considered AP, which means it can run on nodes, many nodes, so it's partition tolerance, but it's also more highly available. HBase, as we'll see, is considered CP, so it is consistent and partition tolerance. Now, all these have certain trade-offs. So if you think of something like Cassandra, where it's available and partition tolerance, it may not, users who use the system may not see the same version of the data all at once. And so that can pose certain problems, but yet then again there may be certain advantages of that. And we call that eventual consistency. So hopefully that makes sense. So when we talk about traditional databases versus NoSQL, which actually people refer to it as not only SQL, this isn't a replacement. Like I said, when you're talking about the CAP theorem, it's all about trade-offs. Is traditional SQL will abstract the details of the storage. So when you're executing a SQL query or implementing a database system, the users don't need to know how the files are laid out. There's an abstraction there. Of course, you have your database files that exist on storage, but then above that are your tables and your your partitions and things of that nature that are abstracted away from the actual storage. There's also the idea that the data is normalized in traditional SQL. So you have the concept of foreign keys, primary keys, normalized first, second, third normalized form. And what the idea behind that is that allows for more ad hoc querying patterns, which is both good and bad. Obviously, when you normalize a system, there's a very tight structure to your database system that requires additional overhead and maintenance and resources to do that. The NoSQL implementation, on the other hand, is usually based off highly structured access patterns. So and what we'll see a lot of times in HBase implementations is you need to spend a lot of time up front defining how users are going to access the database, HBase, in order to eke out the most performance, and we'll see that around column families and things of that nature. So it allows for very efficient but highly structured access patterns, and then also the data tends to be more denormalized and allow for more unstructured or semi-structured data to be put into the system, which can also cause some repetition in data too, some repeat of data. But then again, there's always going to be a trade-off. The idea that the database system also is aware of how it's being stored to the underlying storage within a cluster also allows it to scale much better. So a product like HBase understands the idea of a cluster and how that cluster is organized and arranged. So it allows it to scale horizontally as opposed to just simply scale vertically. And really the key to scaling NoSQL is denormalization. The ability to have repeating data allows the system, or even just partition data, allows the system to be implemented in a distributed fashion. So you can have parts of your data set on one node, another part partitioned on a different node, and the engine behind the data system understands that partitioning. It understands the location of that data, and it can when you execute SQL against the structure, it understands where to get that data within a cluster. So you do have to know your queries a bit in advance, but the trade-off for that, as also which can also be designed in your traditional relational system, is the trade-off with that is that you can fine-tune it and eke out some incredible performance out of your system. Possible millions of transactions per second, very low latency performance out of your system. Of course, it does require some initial upfront engineering. All right, so let's dive down a little bit and look at HBase and where it came from. HBase originally came from a white paper by Google called Big Table, and what it was basically doing is it was trying to do web internet search, and it based this off a key value store. So essentially, HBase is a key value store. So you'll get a unique key, and then beyond that is a value, and that value can pretty much be anything you want it to be. It's completely unstructured value. In the past, we are in the Google Big Table. The scenario was each web page had a URL. So if you think of CNN.com, what they did is they reversed it. So you had com.cnn.ww, and then you had the directory structure of the web page. What that allowed for is it allowed, what we'll also see is that HBase orders all the data within the system. It pre-orders all the data. So when you reverse the URL in the case of Google, you had all the coms listed, and then all the .cnn, and then the www was all listed. So you could do massive scans within the system very efficiently because everything was ordered based off key values. So being scalable horizontally also allowed for petabyte scale, large scales, and there's some 300, 400 petabyte HBase clusters out there. Lots of memory management, supports low latency reads, writes, and updates. So when you think of high transactional processing on Hadoop, they're really talking about HBase. Now we had talked about Hive and TES, but Hive and TES are more for interactive SQL, but HBase is for extremely high, extremely low latency transactional type interactions. And we'll talk about some of the use cases later. So really quick, this is how HBase fits into HDP, the Hortonworks platform. It is just another data access layer within the system running on Yarn. So actually, HBase on Yarn is called Hoya, and it's just another plugin along with Pig, Hive, the Solar, and some of the other in Spark. It's just another, and does ship with HDP and is available in 2.2. It was available in previous versions too. And so when you get the HDP, our distribution, you also automatically get HBase installed. So what HBase essentially does is when you create tables within HBase, you create a there's keys, and these keys will be unique, and they'll have key ranges. And then it very kind of simplified. It takes these ranges and distributes them across your cluster, across the nodes. Each node runs a service called a region server service, and so each region server, each node, will contain a subset of the keys within your database. And this is how it distributes the data across your cluster. Now, there's certain things to think about. For instance, is maybe there could be skew in your keys, a lot more keys within a certain subrange. So that means one region server may contain a lot more data than other region servers. And there's ways around this, but those are all some architecture things you have to consider when implementing HBase. And that goes back to the idea that you have to understand the architecture and the storage of your cluster when implementing HBase in order to get the most performance out of your system. So let's look at a quick scenario. In this case, we're going to talk about Santa's toy delivery. And what we want to do is we want to create a naughty and nice app. And initially, we want to manage the kids' wish list. Santa wants to easily manage toy distribution, fulfillment, and some of the needs are we have to have the kids, we have to have the address and geography, we have to have a wish list, and of course we have to understand we have to know whether they're naughty or nice. So if we look at the traditional approach, this should all be familiar to everybody. This is a very normalized database. You have a kids table, you have their wish list, their naughty list, which is a lookup table, as well as a lookup table with all the possible toys. So the naughty list is a composite table actually that combines then the the kid ID with the naughty. So we have a primary key and then the values. Now the benefit of this, of course, is that it's a very efficient use of space because it removes duplicate values for the most part. So at least within a row. It's very good at simple or very random insert updates and deletes. So for example, if you need to update one row, it's very easy because you only update one row in one place, so it can be very efficient. And you can write a wide range of queries against it and expect some decent performance from it. The problem is that it can't scale beyond one node. Remember, relational database systems grow vertically as opposed to horizontally, and certain queries may not be efficient due to multiple joins and bad indexing. So some of the questions we could ask, right, is within a given state, what toys go to what addresses, and what is the order size by manufacturer? And with any traditional relational system, we improve these queries with indexes, right? Because the last thing you want to do in a relational database is have full table scans across your data. So you create indexes in order to optimize your queries. So in this case, you'd create additional indexes, secondary indexes, because you'd normally have your primary key index. You'd create secondary indexes. In this case, it would be state, kit ID, manufacturer, and kit ID. But how would we approach this in HBase? Very simply, what we'd say is we'd have a kids table, and then within that kids table, we denormalize the data for that child. So we still have a primary key value, which is kit ID, but then we have multiple columns within the table. So we have, in the instance, you have kid 1, which is Billy. You have his address, your state, the toy, the manufacturer, and whether or not he's naughty or nice. The problem is you do have some repeating values. So you've taken out the manufacturer information or the toy information and put it in with the kids data, so you will have some repeating values like Hasbro. You also have repeating states and things of that nature. But what this allows then is you have this concept of a kid all existing within, within a single region server. And then if you wanted to add additional values, then it could potentially be partitioned across multiple region servers, depending on the size. The query will need to require full table scans for this. There is some performance hit due to update patterns, and then there wouldn't necessarily be any high-level language, at least not yet. There actually is now a high-level language for HBase. But if we think about it too, the data that we saw here, back here, the kit ID would be naturally ordered within the region server, and so you would actually get fairly high performance for your full scans. So let's look real quick at this high-level language that now ships as a tech preview in our distribution, and it's called Apache Phoenix. It's an open source product, and this is really cool stuff. This is a SQL skin over HBase. So what Apache Phoenix does is abstracts some of the the HBase get pull put type language, and allows you to write SQL queries against an HBase database. Again, it's not a replacement for your relational database. It's not available yet for general analytics to plug into, and it's not going to be a replacement for your already existing SQL on Hadoop implementations. But it does have the benefit of allowing much faster HBase development time, and you can build secondary indexes on it. So the bottom line is, if HBase wasn't appropriate for your use case, before Phoenix isn't going to suddenly make it appropriate. It's just, if you're using HBase, having Phoenix on top of it as a SQL skin will help speed up your development. So Phoenix is a separate install. So you would have your if you download our sandbox, you would have HBase as your sandbox, and then you would also install Phoenix. You would download the Phoenix package. You'd have to copy jars to each region server. In the case of the sandbox, it'll just be one single node. And then you would copy your jar to the client. And there's some minor configuration changes, as well as restarting HBase. And then once you do that, you're ready to go. Now, if we look back at the table, at the Santa Claus table, this is how you would create the table. And again, it looks just like a create. It's just a create table statement. So it is, in this case, create table kids, your integers, and then your data types. So it really does make it simple. It completely abstracts some of the complexities of HBase away from the developer.
Scott, just one question here that makes a lot of sense. What if the kid is asking for more than one toy?
For more than one toy, that would be another line in the kids table.
Thank you.
Yep. And you know what this doesn't show is also the columns, the name, address, state, toy, manufacturer column. So you could have a kid that has a, let's say they just happen to have a gender, right? And you want to put their gender on there. And they're listed as, Susie listed as female, but nobody else is, that column doesn't apply to anybody else. When HBase stores that data, that column is only stored for Susie. So that's called sparse storage. So it makes it really efficient. So your columns aren't defined by your table. You can have any number of columns. You could have hundreds of columns in there, and if a certain column doesn't apply to another row, then it isn't stored. It doesn't take up space. So if Susie had another My Little Pony, then there would be another row for Susie. Yeah. So that's the trade-off. Again, we're talking about a NoSQL implementation. We're talking about a denormalized structure here. So there is a storage trade-off to that, and a repetitive data trade-off. Now, when we store it, so actually not when we store it, but Phoenix also allows the concept of a secondary index. So again, anybody familiar with relational systems should know this. And what they can do is you can create a covering index. So you can create an index here called state IDX on the kids table, and use state, and you can include the address and the toy in that index, and that will help speed up queries. Now, going back to the question, yes, the NoSQL approach will lead to a lot of data duplication, but then again, it does allow for fast read queries that scale across many nodes. Updates can be challenging because you may have to update multiple rows in multiple region servers across a cluster. Still, within what we call a column family, like in this kids table, HBase is consistent. Which means that as data is inserted into a column family, users who access that column family will all see the same version of the data in a consistent manner. Other implementations like Cassandra don't allow for that, but again, they allow that. That means the writes tend to be faster in a less consistent NoSQL implementation than possibly HBase. So here's another example. Here's an index to help find only nice kids. And this would be address. So if you notice, the index contains the state, and it contains whether they're naughty or nice, as well as the primary key. So the current state of Phoenix right now is it is an Apache incubator project. The basic SQL semantics are fairly solid and is being used in production in quite a few places. It's improving. And the secondary indexing concept idea is still being flushed out. So it's not again, it's a Apache project in flux, lots of development. But I would strongly suggest, if you have interest in HBase, to give it a try and try to leverage your current SQL skills in this regard. So some of the semantic support that they have now is the idea of upserts and deletes, which is very helpful. And then joins. Of course, joins are being worked on to go beyond just hash joins. Limit clauses, order bys, group bys, and your standard, some of your standard select ideas. So, all right, so that's Phoenix. So keep your eyes on Phoenix. Let's talk quickly about HBase HA, and why I want to bring this up because this is a fairly new development in HBase, which kind of helps make HBase a little more popular in the enterprise. So the problem is it used to be in HBase Classic, it used to be that you had these key values stored partitioned by region server, and if a region server went down, that data was unavailable until the data was replicated and the region server came back online. Or simply the data had to be replicated. Once it was replicated, you could read the data. So what HBase HA does now is automatically creates a primary and a secondary region server. So you have a region server that is writable and a region server that has the same data that is readable. So pretty simple. So now when a region server goes down, HBase will automatically switch over to the secondary region server and allow reads against that data until the region server is rebuilt or reestablished, and then writes can occur again. And this was interesting. This was actually came out of a client who requested this. They needed high availability in HBase, and so they wrote the code and gave that code back to the open community, the Apache open community. So there's really three levels of high availability in HBase. The first one is partitions. We mentioned range partitions across servers. The second one is your standard HDFS replication. So HBase data is replicated within the cluster, within HDFS. And finally, the HBase read HA secondary regions. So HBase right now is very, very, very highly available. It's about 2 nines high availability right now. So basic difference between primary and standby is the primary does reads and writes and owns the data, while the standby only has reads, and the data can be somewhat inconsistent with the primary. Very, very possible. So again, that's the trade-off. So, and this is basically called timeline consistency. And then again, it's the idea that we now have secondary region servers within HBase. So let's talk about some use cases. I'm not sure if anybody's heard of the Lambda Architecture, but it's simply what we have when in a lot of Hadoop implementations is you have two opposing data ingest tracks. You have your what's considered your persistent track, in which you have data being in, and this is pretty much how a lot of companies start out, is you have data being ingested directly into Hadoop and stored within HDFS. It's schematized within HDFS through Hive, HCatalog, and then analytics are done. It may even be moved into a different structure, like a a Microsoft appliance and then queried out of there. But what we also have, and what we're seeing more and more companies moving towards, is we have a speed layer up top in which the data is being ingested at extremely high rates, and it's being placed into and this is where the next presentation we'll talk about Storm comes in, is it's being ingested at a very high rate, whether there's messages or sensor data or something of that nature. And there has to be some kind of processing in real time done against that data as it streams through the system. Now that same data can either be persisted, sometimes it's not even persisted, it's just reacted against. And in order to do queries against that data or do lookups or something of that nature against that streaming data, we have to have a very low latency mechanism, low latency transactional mechanism to doing that, and that's where the HBase, HBase comes in, because they can query HBase very quickly and get immediate real-time responses from HBase against that streaming data source. So some common use cases that we see is we see real-time streaming vitals data in healthcare. So traditionally, nurses may take vitals of patients every 15 minutes. Well, if we, what they want to do is they want to stream those vital signs in real time and then create business rules or thresholds against that data in real time for alerting. And again, that's where HBase would come in. Sensor data too, if we talk about something like home HVAC units or thermostats or something of that nature, streaming in some Wi-Fi connection within the house, streaming data about your devices, that would stream into a Storm topology, which will then could have business rules acting against it from HBase in order for alerting or some other process. And then a common thing is also vehicles. So if we look at if you think of like Progressive and their ability to put a chip within a car to get real-time statistics on your driving patterns for insurance reasons, that data would stream also into a Storm topology and could also include HBase for alerting on that stream. So. And then again, in really any use case which requires a key value type process. So for instance, if you want to do if you want to do complex map reduce or something like that, you can use HBase for that. So any key value use case is a good use case for HBase. All right, so what I want to talk about really quick is HBase in Azure. There is an option, and HBase is a feature within HD Insight. So again, just to reiterate, HD Insight is the Hortonworks distribution in Azure for platform as a service. So there's two entries into Hadoop in Azure. One is infrastructure as a service, where you can set up a Windows or a Linux VM and deploy HDP on those VMs, and it's just an extension of your data center. And then there's also HD Insight, which is platform as a service, where you really don't have to think about anything. You just set up HD Insight, click through, set up your services, of which HBase is one, create your cluster name, how many nodes you want, and your storage account, and it'll automatically build out your cluster for you. And this is a high-level architecture view of HBase within HD Insight. You have your gateways, you have your web apps connecting to your region servers, which are essentially HDFS running a HBase service. And then outside of your virtual network is your blob storage. And what's great about HD Insight and Hadoop in Azure. Even with HBase, is your blob storage is separate from your compute. So if you need to bring down your platform as a service, or you want to move to an infrastructure as a service model, you can do that very seamlessly and maintain your data. You don't have to destroy your data or move your data around in order to make that happen. Get very high throughput. Again, that's what HBase is for. And it's very easy to set up and run. So what I'd like to do real quick is let's see if we can switch into a quick demo. I want to make sure everybody can see this. Hopefully you can see the sandbox here. Let me clear this. So this is the sandbox. Let me minimize this here. So what we're going to do is we're going to log in real quick to, actually we can log into HBase. So from the command line, you can do HBase shell. Let me make sure it's still running. Yep, I think it's running. So this is the sandbox. So if you download the Hortonworks sandbox, you'll get all this functionality. And what we can do is we can just create a table called test, and we'll have a column family called CF. Now really everything is based around a column family, and normally in HBase you won't have very many column families, maybe 2 or 3. So you get petabytes of data but only have 2 or 3 column families. So column families can contain a lot of information. So think of it like almost like a dimension or something, a very wide dimension table. So if you have that kids column family, you could have any number of attributes associated with kids. And then we can view it by doing a list. And that just shows that there's a table called test. And then we could just do a quick put where we put into test. We define a row called row 1, and then a column family of A, and then we would have a value. In this case, we'll just call it value 1. And then we can scan. We can scan test, and it didn't like that. Oh, scan test, and that will describe the row. So it's row 1, column family is CF. And if you notice that HBase will always have a timestamp here, you can customize this, but by default it'll do a unique timestamp. So also when you set up HBase in your environment, you'll need to make sure that your time server, you have a time service running on your cluster and that's in sync, because HBase relies heavily on this timestamp. But you can create your own unique key in order to uniquely identify each row. And we can get it, and that's basically a select from the table. So that's HBase. So let's see what it looks like. Let's see what it looks like in Phoenix. So what we can do is Phoenix. You can connect to Phoenix, or technically you can connect to HBase with any JDBC connection. So and you can connect to Phoenix with any JDBC connection. So you don't have to use the command line. What you can use is you can use a editor tool like Squirrel, SQL Squirrel, or Squirrel SQL. Sorry, and you can set up a Phoenix driver, and then you can connect to it through JDBC. So you have a SQL editor to use against to run to build your queries and run them against HBase. So we're just logging. As you see, it's a JDBC connector here called Phoenix at the local host. And then if we want, I've already loaded some tables, so we can take a look at the tables. And what I like about Phoenix too is that it formats your output very good. So if you notice, there's actually 3 tables that I created manually, which is stats, stock symbol, and webstat. These other tables were created on their own by Phoenix when Phoenix was first run, and these are system tables that Phoenix uses. But these are the tables that I created, and you can simply just do a select star from webstat. And these stats and stock symbol and webstat tables, these actually ship with the Phoenix install. So there you go. There's a table, and keep in mind that this is running against HBase right now. And from here, you can do more complex. Querying. Like if we want to look at something a little more SQL-ish, a little more analytical, you can select the average CPU usage and things from webstat. And there you go. So you can get more analytical. And another interesting too is there is actually an explain plan that comes with this. So you would use the explain plan when you're building secondary indexes within Phoenix in order to determine whether you're gaining performance or not, or how the query is executing against your data, and whether or not the secondary index is helping or not. So keep in mind this is running on my sandbox, on my laptop. Did I hit enter? Oh, I didn't hit enter. And there you go. So this is the plan. It does a full scan on WebStat and then aggregates it into distinct rows by domain. It does a merge sort and then sorts by domain descending. So anybody familiar with SQL explain plans, this should look fairly familiar. And we go back to the deck. That's it for the day. So I will be happy to take any questions. We have about 10 minutes left. So more than happy to take some questions.
Sure.
If there's any out there.
Okay, let me see what we've got. Well, thank you very much, Scott, for joining. For the attendees, make sure you fill the evaluation when you leave, so you will enter the raffle of three $50 Amazon cards. So let's start with questions. Why full scan instead of index scan?
Why full scan? Well, I didn't create any indexes on that data set. So, and plus, just like in SQL Server, the data set was extremely small, so it probably is going to do a full scan no matter what I do. But if there is a lot more data, then I'm going to want to do a secondary index, possibly a covering index, and then we would see in the explain plan, we would see that Phoenix would use the index as opposed to a full table scan. And it is very possible too to have the entire query get satisfied within the index, so it wouldn't even ever have to actually touch the data on this. So you can get very efficient. So just my examples were so small that it was going to probably do a full table scan no matter what I did.
Great.
Now keep in mind too, sorry, just real quick, keep in mind too, HBase will be fairly efficient in full scans because the data is always stored in order format.
Okay. So is there any guide available to install Phoenix in Hortonworks Sandbox?
that there may be a tutorial. I'm not sure. I'm going to have to track that down. There is a guide on the Apache Phoenix website. So when I send out these slides, I'll have some links to that.
Yeah, and here.
And of course, I'm always available too. I can actually, you know what? I can send out. I'll add a slide that has a bit more detail involved for setting up Phoenix.
Yeah, and I guess if you go to HBase in Azure, you'll find out of resources there on how to start with HBase.
Yep, I'll have a I'll have a resources slide that I'll send out. I'll send that out to you, Paco. You can
Yep, I will
forward
post it,
and it will have links to the Azure stuff and some Hortonworks information, and HBase and Phoenix and everything. Hopefully, it'll get you started.
One question is there any limit to columns?
You know, as far as I know, there isn't. I'm sure there's a practical limit. Now, keep in mind too, HBase is it's an extremely deep technology. So I mean, you know, like SQL Server or any other tech, but HBase can be very is very complicated, but extremely adaptable and extremely useful. So there is you know, there's a lot of information out there. You know, some people make their entire living just on installing, developing, tuning HBase, just like in the relational database world. So I don't know the answer to that. I certainly track that down. I think there's a practical limit though, and it's very large. It's very large. Now, column families are a different story. Column families, in something like a Cumulo, which is another NoSQL, you may have, you know, hundreds of column families. But for HBase, you normally you would not want more than maybe 2 or 3 column families, no matter the size of your data.
Okay. So, is it possible to create a Phoenix view on top of HBase table without knowing the number of the HBase column?
Yes, I believe there is. You can create views. You have to look into the Phoenix documentation, but without knowing the column, yeah, you can just do a. I mean, you can do a. That's a good question. I can't recall if Phoenix allows for wildcards in their columns definition or not. But that's a good question.
Yeah, no worries.
Yeah.
Please email it to bigdata@sqlpass.org. That's the virtual chapter email, and we will reply to you. Thank you. Let's see. What about rollbacks and backups?
No. So Phoenix doesn't have the idea of a transaction. So there are no rollbacks currently in Phoenix or commits. Now, HBase does have versioning involved, and you can go back to other versions within HBase, and you can set that limit so you can determine how many versions to keep and the compaction frequency. So when you make a change in HBase, it'll actually create another version of the data and then periodically compact the data into a single row. So, and that's all configurable. So within HBase, you can keep multiple versions of the data and access multiple versions of the data.
Okay, can we directly get data from Excel through GDBC connection from Phoenix? Or do you know any other way to browse data with Excel to Phoenix?
I don't see why not. I haven't tried it myself. So Phoenix does use a JDBC connector. So now what I would probably suggest doing, and I forgot to mention this, is you can create Hive tables and use a Hive storage handler on your table So you can create a Hive table that points to HBase. So you can have similar Phoenix functionality, but you could actually access HBase through Hive. And now Hive, you can use ODBC connectors into a Hive table that accesses HBase.
Cool. Any analytics data on how big and how fast to build indexes?
How big or how fast to build indexes?
Yeah, the question, I guess, is assuming when to build an index in terms of size and what the performance of these indexes are.
It's more of an art than a science. It really depends. Of course, with any system, there's a trade-off between having an index to speed up queries and whether that index will might cause issues or performance problems with your inserts in order to build the index. So it's a trade-off. I don't have any specific numbers on it. I would just say if you're running queries and you start to notice a little slowdown, go ahead and build an index and see if it helps. If it doesn't help, then don't have the index.
Okay, so I'm going to read 3 questions in one, okay?
Okay.
What should be the data volume to use these tools? When would you choose to go with HBase for an OLTP solution over relational database management system like SQL Server?
Yeah.
Yep.
So yeah, that's a great question. I'm not, I'm certainly database size isn't always the issue. This is complex stuff, and it's much different. Like I said, it's much less HBase and other NoSQL situations. They're much less abstract than traditional relational database systems, right? A lot of these systems, if you think of like a MongoDB or something, they were developed for developers. A lot of times they were developed because developers didn't want to know SQL. They didn't want to learn SQL, and SQL and the SQL language was an impedance mismatch for them. They wanted to write directly to the data and not have to worry about going through a DBA and things of that nature. So when you're making a switch from a transactional system like SQL Server into a NoSQL implementation like HBase, you have to take into account a lot of other things than just the size of your database. You're going to have to take into account the skill sets, the learning curves, how your applications are written, how your queries, what queries you want to get out of it. At Hortonworks, we usually define the use of HBase around specific use cases, and these use cases are definitely not on the side of necessarily transactional use cases like your day-to-day OLTP systems. They're more on use cases around high transactions for real-time analytics, which is much different.
Great, thank you. Can you load the table in memory?
Yes, it will load in memory, yeah. So HBase actually uses quite a bit of memory at the region server level.
Great. Okay, last question. Can you use data warehouse traditional schema designed on HBase, or will the data warehouse schema design be totally different?
Nope. You can use so you can use Phoenix or Hive, and you can recreate the structure in your data warehouse to you can recreate that structure within HBase. So you can simulate your dimensional model in HBase that you have in your data warehouse.
Great.
Yep. And a good example is you can do the TPCDS is what is traditionally the schema to test data warehouse functionality, and then you can actually load that with it. You can load that into HBase using Phoenix.
Great. Okay, thank you very much, Scott. That was a great presentation, and great answers to our attendees' questions. Thank you all the attendees for being here for this session and asking so many good questions. We'll see you in next session. Remember, for this educational series, next session will be February 24th. Check the website for the past Big Data Virtual chapter. That is bigdata.sqlpass.org. And over there you will find extra materials for this session plus the recording. Well, thank you very much for attending and see you soon. Thank you, Scott.
Thank you. Thanks, everyone. Bye.
Bye.